Good morning all. How are you all? Doing good? Very good. So today we are going to learn a new topic in our physics. And first of all, let me ask you something. You have all traveled in a bus, isn't it? You have all traveled in a bus. How many of us traveled in a bus by standing in a bus? By standing in a bus, how many of you have traveled? Yes, all of you have traveled by standing in a bus. Then, my question is that we are traveling in a bus and suddenly the brake is applied. Okay, suddenly the brake is applied. What will happen to us? What will happen to us? Very good. We will fall forward. We will fall forward. Very good. Then, if you are standing in a bus which is at rest, okay, then it's not moving. It is in a bus stop, and it is not moving. And suddenly the bus starts. What will happen to you? You are standing in a bus, and the bus is not at movement just now, and just it started. What will happen? Very good. You will fall backward, isn't it? You will fall backward. So when the brake is suddenly applied, you fall forward, and when it started suddenly, you fall backward. Do you know what is the reason behind all this? What is the reason behind all this? Any idea? No, no idea. So let us find out what is the reason behind all this. And today our topic is motion and laws of motion. Motion and laws of motion. So let us start our class. And first we are going to do an activity. Watch it carefully and answer my questions.
This is a fully filled bottle which is initially at rest. I'm going to flip this card suddenly. You should observe it carefully. You can see that the bottle falls in the opposite direction where the force was applied. Of the bottle showed a tendency to remain at rest.
Have you watched the activity? Yes. Then my first question is that what was the state of that bottle before we pulled the paper? What was the state of the bottle before we pulled the paper? Yes, it was at rest, isn't it? It was at rest. Then what tendency did its cap portion or top portion show when you pulled the paper? What tendency did it show? Yes, it showed a tendency to remain at rest. It showed a tendency to remain at rest. And then what happened? What happened to that bottle? Yes, it fall down, isn't it? It fall down. In which direction it fall down? In which direction it fall down? Very good. It fall down in the, isn't it, opposite direction of our pull. It fall down in the opposite direction of our pull. Very good. So, you have learned that at first the bottle was at a state of rest. And the bottle show a tendency to remain in its state of rest. And as a result, it fall down, isn't it? So, if a body in rest is showing a tendency to remain in its state of rest, that phenomenon, that property is called as inertia of rest. Inertia of rest. Inertia of rest. That is the tendency to remain in rest. If a body is in rest and it have a tendency to remain in rest, and this property is known as inertia of rest. Are you clear with the topic inertia of rest? Now observe another activity.
Again, take a fully filled bottle and move it constantly to make it in motion. Now it is in the state of motion, and suddenly we can see that it falls in the same direction of the force. The bottom part stayed in motion.
Have you observed the activity? Yes. Then in this case, was the bottle at rest or motion? It was at motion, isn't it? We were constantly pulling it, and it was at motion. Very good. And when we pulled the card, which part of the bottle showed the tendency to stay at motion? Which part showed the property? Very good. The bottom side of the bottle. Bottom side of the bottle. And when we pull the card, what happened to the bottle? It fall down. In which direction? Which direction? Yes, towards the direction of our pull. Same direction of our pull. So you have learned a body in motion will have a tendency to remain in its state of motion, and that property is called inertia of motion. inertia of motion. So you have learned what is inertia of rest, and if it is to have a tendency to remain in motion, it is called inertia of motion. So you have learned two types of inertia, inertia of rest and inertia of motion, isn't it? Very good. Now observe another activity. Observe another activity. Here we have a box for our activity. A box for our activity. And first, it is filled box, isn't it? It have lots of paper paints in it, and it's a filled box. What I'm going to do is, now I'm going to place this box on my hand. On my left palm, I have placed it. Now what I'm going to do is, I'm just going to lift this bottle up. I'm going to apply force to lift it up. I have lifted up, isn't it? Now what I'm going to do is that I'm going to remove all these paints from this box, and I'm going to make it an empty box. Let me remove it all. 2, 3, 4, 5, 6. Now you can see it is an empty box, and I'm going to close this box. It is an empty box and I have closed it. Now I'm going to place similarly as I have did for the weighted box. Now I'm going to lift it up. So you have seen the two cases. First one was it was filled and I have lifted it up. Second case it was empty and I have lifted it up. Now my question is that which box was easy to lift up? Which box was easy to lift up? Yes, the empty box was easy to lift up, isn't it? Empty box was easy to lift up. Is the force applied in both the case same? Is the force applied in both the case same? No, isn't it? It was not same. Why it was not same? Why the force was not same? Why? Yes, the force was not same because there was a difference in the mass. First it was more mass, it has more mass, and second case it has less mass. Yes, it has a difference in its mass. So the force was not same. First it was having more mass, and the second case it was having less mass. So can you say, is there any relation between this inertia and mass? Very good. When mass increases, inertia also increases. When mass increases, inertia also increases. So we have learned another property of inertia, and the property was inertia is directly proportional to mass of a body, isn't it? Mass of a body, because when mass increases, inertia also increases. When mass decreases, inertia also decreases. Very good, you have learned that too. So today we have learned what is inertia of rest, what is inertia of motion, and then we have learned the relation between inertia and mass. So now we have some assessment questions or follow-up activities here on the screen. Your task is to complete the questions along with its answer and write it in the science diary and send it to me. That's all for today. Have a nice day. Thank you.